next topic is the important basic topic is nodal analysis and node voltage analysis. So this is similar to your mesh loop analysis where we use loop currents, assume loop currents, and then we find all branch currents. Similarly, in this case, nodal analysis or node voltage analysis, we are going to find the node voltages. Using node voltages, we can find currents in all branches. So this is also very basic or method to solve a circuit. The ultimate aim is to find the response, that is current. So in branches, in each branch of the circuit. So in this method, we are going to make use of node voltages. So I will show you a simple diagram, circuit diagram. From that I will tell you how to find node voltages like that. Okay. So before that, steps involved in node analysis. What are the steps involved in node analysis? First thing, the very first thing is, the first step is, whenever you look at the circuit, you have to find number of nodes. How we in mesh loop analysis we found for number of loops. The same way here we have to look for number of nodes. So before starting a problem, before starting or before going into the problem, we must assume a reference node. That is very important. We have to assume a reference node. Okay. So including reference node. So total number of nodes including reference node. Number of nodes and plus this reference node. From that we can find number of equations we are going to get. So n minus 1 equation. We have to form n minus 1 equations. That is including reference node. For example, if you are having 5 nodes, for example, the circuit including reference node, then n minus 1 equations have to be formed. That is 5 minus 1, 4 equations have to be formed. So this is a method. First we have to find the nodes and we have to mark a reference node. Then from that we can understand, we could find that how many equations we have to form. Next one is using Kirchhoff's current law at each node. So we have to apply Kirchhoff's current law at each node and we have to form the equations for each node. After that, solving equations, we get node voltages. Solving equations, we will get node voltages. Once node voltages are known, we can find branch currents. After that, using node voltages, we can find branch currents. So these are the steps involved in node voltage analysis or node analysis. So I will show you using a basic circuit. I will show you how to form this equation, how to find this node voltage, and how to find branch currents using that equations. Okay. A circuit. I will show you a circuit. I have shown a circuit with the two current sources, I1 and I2, and I told you whenever we are starting to solve a problem, first thing is if I am solving with node voltage analysis, first thing is I have to mark the reference node. So you can see here, this is your I am going to take this as reference node. Normally the potential at this node will be 0 volt. So I can, once I go through this circuit, I can find this node 1 and you can find node 2 and this node 3. What is a node? Node is a combination or the place where two or more branches meet. That is called a node. So you can see here this current source, resistance 1, resistance 2 connected to the node. And at the node 2 you can see R2, R3 and this source is being connected. And this is taken as reference node. And the voltage referred to this node is 0. So for each node I can give name, I can measure voltage at each node. So let us name the voltages at that nodes as at reference at node 1 voltage is V1 and at node 2 node voltage is V2 and this reference node voltage is 0. So reference node is marked. Our number of nodes including this reference node is 3 nodes are there. 3 nodes are there. So we need n minus 1 equation. N minus 1 equation. That is in this case it is 3 minus 1. It is 2 equations we are going to form. 2 equations we are going to form. Something here. So next step is to apply Kirchhoff's current law. To apply Kirchhoff's current law at each node. Okay. So before going to apply Kirchhoff's current law each node, I am going to mark the branch currents. So let us see. At this branch you got the current name as I1, and so that I am going to mark this the current flowing through R1 as, for example, I2. Since I have marked here I1, I can mark current flowing through R1 as I2, and current flowing between the two nodes 1 and 2, that is through R2, may be referred or may be assumed as I3. And similarly, already there is a current flowing towards this node. This is marked as I2. And current flowing through R3, this branch can be taken as I4. So I have given, we have to mark branch currents. For each branches, we have to give names, individual names. So here it is I1, here it is I2, I3, I4 and I2. Now let me start with the first node at node 1. At node 1, apply Kirchhoff's current law. Apply Kirchhoff's current law. So in this case, Kirchhoff's current law states that sum of incoming current is equal to sum of outgoing current. So I is equal to, I1. You can see I1 is the current flowing towards the node, and I2 I will mark here. Sorry, you can make this as I5 and get side. Okay. So now you can see I2 and I3 are leaving away or coming out of the nodes. So towards the node is I1 and current leaving the nodes are I1 and I3 at node 1. So I1 is equal to I2 plus I3. So sum of incoming current is equal to sum of outgoing current. Now I can write equation for these two currents. What is that? I2 is simply, the current I2 is simply current flowing through R1, that is V1 minus 0 divided by R1. So I1 is equal to V1 minus 0 by R1. Sorry, I2. Okay. For I1 is already given. Okay. So I2. So V1 minus 0 divided by R1 is your I2. Similarly, I can find I3. I3 is the current flowing between node 1 and 2. That is V1 minus V2. So V1 minus V2 divided by R2. This is your I3. So once you find I2 and I3, now you can substitute over in the equation. So I1 is equal to V1 by R1. Sorry, I2 plus I3 is equal to V1 minus V2 divided by R2. So now we can simplify it. Once we simplify, we get I1 is equal to V1 1 by R1 plus 1 by R2 minus V2 by R2. So this is your equation number 1. Now let us go with the second node. Let us find the equation at the node 2. once if we go to node 2, in this case apply Kirchhoff's at node 2 apply Kirchhoff's current law. Once if you apply, you could find I3 is incoming current, and at the same time I5 is also incoming current is equal to I4. So sum of incoming currents are I5 and I3, and sum of outgoing current is only I4 here, current going through R3. So I have one like this. So now I can find again only for I3. I have found the equation I3 as V1 minus V2 by R2, and I5 is a simply source given. So I can rewrite the equation like this: I5 is equal to I4 minus I3. Okay. So what is I4? Once you got I4, you can see what is I4. I4 is the current going through R3. Therefore V2 minus 0 divided by R3. So I4 can be written as V2 minus 0 is again V2. V2 divided by R3 is your I4 minus I3 is simply V1 minus V2 divided by R2. V1 minus V2 divided by R2. So once if you simplify this, you will get minus V1 by R2 plus V2 divided by V2 into R2 1 by R2 plus 1 by R3. 1 by R3. So now you can make this equations 2. So now we got two equations from the diagram. Now we can model this one into matrix, so that after giving matrix format you can find Cramer's rule, so that you can find the unknowns V1 and V2. Once if you know V1 V2, we can simply write the if you want I2 current flowing through R1 is I2. Once we need current flowing through R1, just by finding V1, we can simply divide V1 by R1. I can get I2. Similarly, if I want I3, once if I know V1 V2 minus those two voltages divided by R2 value gives you this I3. Similarly, you can find current flowing through R3 also. So next step is to make this one into a matrix format. So this is your matrix format. So in the last topic, Westloop analysis, I put R matrix, I matrix is equal to V matrix. In this case, it is G matrix because 1 by R is all conductors. So G matrix, V matrix is equal to I matrix. G matrix, V matrix is equal to I matrix. So from this equation 1, I can write the unknowns of V1 and V2. I can write the coefficients of V1, the first one, first row, first column element. So it is simply 1 by R1 plus 1 by R2 is your first element of this G matrix. And the second one, coefficient of V2 is minus 1 by R2. Similarly, if you come to the next equation, in this V1 coefficient is minus 1 by R2, and here it is 1 by R2 plus 1 by R3, and here it is I1 and I5 are the known values of current. So once you form this matrix using Cramer's rule, find V1 and V2. Thank you.